for number 7. The temperature of, and at 55.6, so grams tells me that's mass, decreases by 14.8. So it's going down when it loses this much energy. So the thing is these things are both negative, and it doesn't really matter if I make them both negative because they're going to end up canceling out. It wants me to find specific heat, and specific heat is never negative. So when I plug this in, if I'm doing this totally correct, it's losing this much energy. 55.6 grams is its mass. Decreases by 14.8 degrees Celsius, and I'm solving for specific heat. So mass and specific heat are never going to be negative. The only ones that can be negative are joules, and that tells us we're releasing energy, and delta T, that tells me that temperature is going down. So I'm going to simplify by multiplying my 55.6 times negative 14.8, oopsie, equals 55.6 times negative 14.8 equals, so negative 822.88, and that's going to actually divide both sides by that, negative 822.88, and that's grams, not Celsius. Now, when I divide those two, the negative is going to go away. And so if you just remember that specific heat is never negative, a lot of times people forget and like include one minus sign but not the other. If you just remember that it can't be negative, just drop the negative sign. The values are generally not the problem. It's the signs that we forget. Okay, so equals. So this is what I'm looking at for specific heat. Again, 3 sig figs, 3 sig figs, 3 again. It seems to be kind of standard. So 3.74 joules per gram degrees Celsius, which is exactly what this unit would be if you look at the numbers, like grams dot Celsius, divide both sides, joules per gram degrees Celsius is going to be the specific heat unit.